Hello students, welcome once again to our channel. In this video, we are going to see Class 12 Physics, Unit 3, Magnetism and Magnetic Effects of Current. This is the second derivation of this lesson. Derive the expression for the magnetic field at a point along the equatorial line due to a magnetic dipole. In other words, a bar magnet. Now, here comes the diagram. This is the bar magnet and these are its two poles, south pole and north pole, and this is the geometrical center of this bar magnet O. Now the distance in between the south pole and O is L, and from O to N it is another L. So altogether the magnetic length of this magnet is 2L. Now, if we consider a line along this O, I mean the center, which is perpendicular to this bar magnet, this line is called as equatorial line. On this line, we are going to consider a point which is named as C. At this point only, we are going to find out the magnetic field. So in order to find out the magnetic field, we are supposed to place a north pole over here. So just imagine there is a north pole over here. What happens? This north pole repels this north pole. We all know that like poles repel each other. So this north pole repels this north pole in this way. So this arrowhead is drawn in this way. So this is the direction of the magnetic field due to this north pole. Similarly, this south pole attracts this north pole. We all know that unlike poles attract. So this is the direction of the magnetic field due to this south pole. So this arrowhead is drawn in this way and it is denoted as BS vector. Now what is the direction of the resultant magnetic field? Which is in this direction. Neither in this direction nor in this direction, but in between these two magnetic field, which is in this direction, which is denoted as B vector. Now the distance in between the center of the bar magnet and C is R. Now join S and C, similarly N and C. This distance is R dash. In the same way, this distance is also denoted as R dash. Here a small graphical representation is given. This is the x-axis and this one is the y-axis. Now I cap is the unit vector along the x-axis and j cap is the unit vector along the y-axis. This is the positive x direction, so this is plus I cap, and this is the negative x direction, so it is denoted as minus I cap, and this is the positive y direction, so j cap. Here this is the negative y direction, so it is denoted by minus j cap. Now from the diagram, let us consider this one, this triangle, which is a right angle triangle, this one. For this we are going to apply Pythagoras theorem. What does Pythagoras theorem say? The square of the hypotenuse is equal to the sum of the squares of the other two sides. So let us take this right angle triangle, which is the hypotenuse R dash. So R dash squared, which is square of the hypotenuse, is equal to the other two sides. One side is R and the other side is L. So square it and also square this one. And sum it, add it. R squared plus L squared. This is what the Pythagoras theorem say. Now, take the square of what happens this side? It becomes square root. Now this square root can also be written in this way. R square plus L square to the power of 1 by 2. So we have got the expression for R dash, and also we have the expression for R dash square. Now in the next step, we are going to find out cos theta. What is the formula to calculate cos theta? Adjacent side by hypotenuse. From the diagram we all know that the adjacent side is L and the hypotenuse R dash. We have already found the expression for R dash. That's what we have over here. So in the place of R dash, let us write R square plus L square to the power of 1 by 2. Now, explanation. Explanation. N, S, north and south poles of a bar magnet. Then Qm. What is Qm? Pole strength. Then 2L, magnetic length. O, geometrical center of a bar magnet. Now C. C is nothing but a point on the equatorial line at a distance r from O. Now we have taken the upper portion of the diagram, what we have seen previously, and drawn it in an enlarged manner. This is the Bn vector and this one is the Bs vector, and this is the direction of the resultant vector, we all know that. And here also let us draw a line, perpendicular line, extend it downwards. Now we are going to find out the components of this Bn vector. Its vertical component is Bn sine theta, and this is in the positive y direction, so j cap. And this is the horizontal component of this Bn vector, that is Bn cos theta, and this one is in the negative x direction, so minus I cap. Similarly, we can resolve this Bs vector also into two components. One is the vertical component and another one is the horizontal component. The vertical component is Bs sine theta, and moreover this is in the negative y direction, so minus j cap. And this is the horizontal component of this Bs vector, that is Bs cos theta, and this one is in the negative x-axis, so minus I into theta. Here in this box a small note is given, which is nothing but the expression for magnetic field. That is B vector is equal to mu naught by 4 pi Qm by R square. This is the basic formula to calculate magnetic field. Keep it in your mind. Now, the magnetic field at C due to the north pole is. So, the magnetic field at C due to the north pole is Bn vector is equal to, we need to write both of its components. I mean to say both the horizontal component and the vertical component, and we need to sum it up, we need to add it. So we get here minus I cap is there, so that minus comes before. So minus Bn cos theta I cap plus Bn sin theta j cap. Let it be equation number 1. Here the magnitude of this Bn is nothing but what? Mu naught by 4 pi. Here mu naught by 4 pi and Qm by R square. But here according to the diagram this is not R, this is R dash. So we also write R dash square. Similarly, the magnetic field at C due to the south pole is Bs vector. Again here also we need to sum them. What and all? The horizontal component of Bs vector and the vertical component of Bs vector. We need to add them up. So, the horizontal component minus I cap is there. So, we have brought the minus over here. And in the vertical component also, minus j cap is there. We have brought the minus over here. So this is what this expression. Here the magnitude of this Bs is nothing but mu naught by 4 pi into Qm by r squared is the basic formula. Here the distance is r dash, so r dash whole square. From equations 1 and 2, the net magnetic field at point C due to the dipole is. So far we have found the magnetic field due to the north pole and south pole separately, but here we are going to see the magnetic field at point C due to the dipole. So B vector is equal to Bn vector plus Bs vector we can write. Here B vector is equal to Bn vector plus Bs vector we have written. So the expression for Bn vector is written over here, plus within bracket the expression for Bs vector is also written over here. In the next step, minus Bn cos theta I plus Bn sin theta j, everything we have written, plus into minus minus, again plus into minus minus. So minus Bs cos theta I cap minus Bs sin theta j cap. Here the magnitude of both Bn and Bs are same. So in the place of Bs we can also write Bn. So in the next step B vector is equal to, this step is written as it is, but here in this step wherever Bs comes we need to replace it with Bn because the magnitude of Bs and Bn are same. So here minus Bn cos theta I cap minus again Bn sin theta j cap. These two terms are similar. Here this term and this term get cancelled out. So these two are remaining. Therefore B vector is equal to minus Bn cos theta I cap again minus Bn cos theta I cap. So in these two, what is common? Cos theta I cap. So we can write it like this. B vector is equal to, minus is also common, so take it out, minus within bracket Bn plus Bn cos theta I cap, take it out as it is common in both the terms. So in the next step, therefore B vector is equal to minus Bn plus Bn 2Bn cos theta I cap. Let it be equation number 3. Now substitute the expressions of Bn and cos theta in equation 3 we get. We all know that the expression for Bn we have already found out. Similarly, we have already found out the expression for cos theta. Let us substitute the expressions of cos theta and Bn in this equation. So we get B vector is equal to minus 2 into mu naught by 4 pi Qm by r dash squared into, in the place of cos theta, L by r square plus L square to the power of 1 by 2 I cap. In the next step, minus mu naught by 4 pi Qm by, we have already found out the expression for r dash square, that is r square plus L square into L by r square plus L square to the power of 1 by 2 into I cap. In the next step, we have written like this, minus mu naught by 4 pi, this 2 is brought over here. So 2 into L, 2L, it is written beside Qm into I cap, and here this r square plus L squared into r square plus L square to the power of 1 by 2, it gives r square plus L square to the power of 3 by 2. Now let us see how this 3 by 2 has come. Here a small note is given for your better understanding. Here a is there and here a to the power of 1 by 2 is there. Now we are going to multiply these two terms. A is there means there is no power, it means the power is 1. So in the next step, a power 1 into a power 1 by 2. Here bases are same, so powers get added up, which is equal to a power 1 plus 1 by 2. Now take LCM or cross multiply this one. it becomes 2 plus 1 by 2. Write it in common. In the next step, which is equal to a to the power of 2 plus 1, 3 by 2. So, a into a power 1 by 2 gives us what? A to the power of 3 by 2. Similarly, these two terms are same. Here power is 1, but here power is 1 by 2. So, when they get added up, when they get multiplied, the power becomes 3 by 2. In the next step, minus mu naught by 4 pi, we all know that Q into 2L, here M is not written, you make note of it, Qm into L is equal to what? Pm. So in the place of Qm into 2L, I have written Pm. So minus mu naught by 4 pi into Pm by R squared plus L squared to the power of 3 by 2 I cap. Now, in comparison with this R, the distance, the L is very, very small. So, therefore, if we neglect L squared in this term, we get R squared to the power of 3 by 2. Again, this 2 and this 2 get cancelled. Finally, we get R to the power of 3. So, in the place of this one, we can write R power 3. So in the next step, we get B vector is equal to minus mu naught by 4 pi into Pm by R cube into I cap. Again, this Pm into I cap becomes equal to Pm vector. So here, take this term Pm I cap and in its place you better write Pm vector. So finally we get B vector. B vector means what? Magnetic field at the equatorial line. The expression for it is minus mu naught by 4 pi Pm vector by R cube. This is the final expression for magnetic field along the equatorial line. So with this video has come to an end. Let us continue our studies with another derivation in the next video.